Okay, so what we concluded in the previous video was very important. If you did not see the previous video, or if you have forgotten what you uh, learned in the previous video, just revisit that video and especially look at the end of the video, because that is what we are going to be starting from here. So in the previous video, we saw how negating the x-axis is kind of leading to the reciprocal of that curve in the previous video. So here we're going to talk about one interesting property of reciprocals, which is that if you reciprocate a number, a in this case, you basically are raising it to -1. And if you take the reciprocal of this, you're going to get back this. So the reciprocal of a to the power 1 is a to the power -1, and the reciprocal of a to the power -1 is a to the power 1. And it's kind of interesting. And if you replace this 1 with x, this has kind of a flipping effect already, right? So if I replace that 1 with x, which means that if I have a to the power x as my beginning number, then if I find the reciprocal of that, it becomes a to the power -x, and the reciprocal of this is again a to the power x. So this is kind of the same as flipping the x-axis, right? So if we use this as the equation of our curve, then it is already fitting our requirement for the curve. So this has to be the equation of our curve in the previous figure, which was this. So the equation of this curve is nothing but a to the power x, and the equation of its reciprocal is a to the power -x, which is also equivalent to flipping the x-axis, because if you flip the x-axis, then a to the power x becomes a to the power -x, because you're just negating the x-axis, and that is nothing but equivalent to the reciprocal of this curve. Now in the next video, we're going to talk about how we're going to use this equation and do what we can do to come up with our line, which will be finally converted to this curve and then finally converted to the bent line that we want to get to.